For your Chapter 11 test, it will look just like the review, and that those 5 formulas that are at the top will be at the top, but they are not labeled as to what they are used for, so you need to recognize which formula to use for what. So the first one is for an arithmetic sequence. The second one is for a geometric sequence. The third one is for an arithmetic series. That's where we're finding the sum of terms. The fourth one is for a geometric series. And the last one is for an infinite geometric series. So the 5 formulas will be provided for you, but not what they are used for. So you need to recognize the formulas to know which one to use at which time. Okay. Arithmetic means that we're adding terms, so that has a D in it for common difference for the sequence. And geometric means that we're multiplying by the same thing over and over, so that has our R in it for ratio. Likewise with the series, has that R in it for ratio as well. Our first type of question asks us, is it arithmetic, geometric, or neither? So arithmetic, what are we doing term to term? Adding. So that's what we'd look for there. And geometric, we are multiplying by something. And then if it's not one of those, then we just say that it's neither. So number 1, and this 108, by the way, should actually be over with that negative on number 4. The margin got messed up there. So number 1, what is that one doing? It's arithmetic. It's adding. Number 2? Geometric. We're multiplying by 2. Number 3? Neither one. It adds 1 and then 2 and then 5 and then 7. Multiplying doesn't work either, so that one doesn't fit either one of those patterns. And what about number 4? Geometric, what are we multiplying by? Negative 3. Questions on that? So make sure. You don't need to, since it doesn't say explain. If the directions would say explain, then you would need to tell what the difference or the ratio was. So just make sure you know those 2 terms and can identify when to use them. Stupid questions, we're asked to find 6 terms. We do that by starting by plugging in 1 and going from there, then plug in 2, etc., until you plug in 6. You do not need to show your work the way that I'm showing it. You could just list out your 6 answers. But if you do that and they are wrong, then I can't give you partial credit, as opposed to if I see that you knew you were supposed to plug in 1, 2, 3, 4, 5, 6, but you must have hit a wrong button on your calculator, then I could still give you partial credit. But if you're feeling really good about just plugging stuff in, then you could just give me the list of 0, 3, 8, 15, 24, 35 would be fine, and just separate them by commas. Okay. Questions? All right, go ahead and try 6 and 7. Plug in 1 through 6 on those. All right, so let's look at number 6 and 7 here. So for number 6, when I plug in a 1, I get 0. Plug in a 2, I get 4. Plug in 3, I get 12. Plug in 4, I get 24. Plug in 5, I get 40. Plug in 6, I get 60. And like I said, you don't need to show any work. If you just list them out by commas, that's fine. So like number 7 is pretty straightforward. Should have negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. And that would be totally acceptable to just list them out by commas as well. Okay. Questions? to write the next term and then to write the rule for the nth term. When we say about writing a rule for an nth term, those are our explicit rules. It means that the formula should just have an n in it, not like the recursive rules that we talked about in the last lesson. So for these ones, we're going to figure out, is it arithmetic or geometric? Find out what the next term would be, and then apply the appropriate formula from the top of the test, either the arithmetic sequence formula or the geometric sequence formula. So on number 8, is it arithmetic or geometric? Arithmetic. What are we adding? 4. So our next term would be 24. Then it also asks us for the rule. The rule for arithmetic is a sub 1 plus n minus 1 times d. And we're going to plug in the appropriate values for this particular sequence. A sub 1 means first term, which is 8. Common difference means what we're adding, which is 4. Then you need to clean up combining like for your final answer. So distributing turns that into a 4n minus 4. And combining like terms gives us a final answer of a sub n is 4n plus 4. So we know our next term, which we find by figuring out the pattern and following it out to the next term. And then our rule, which we can use the arithmetic sequence formula from the top, and just make sure that you distribute and clean up. Questions on that one? I'm going to jump down to 11. What type of sequence is that? Geometric. What are we multiplying by? 2. So our next term would be 32. And we use the geometric formula, which is a sub 1 times r to the n minus 1. A sub 1 means first term, which is 2. R means ratio, or what we're multiplying by, which is also 2. We cannot combine those 2's and make them a 4. That does not work. So we just leave it right there. It could technically also be written as just 2 to the n, but you don't need to worry about that. Okay. Okay, so most of you will probably have the form that's boxed in, but it could be written the other way as well. Yes? I distributed number 8 because it was a multiplication. It's n minus 1 times 4, so that's when we distribute, whereas in number 11, that's an exponent, so we can't distribute out an exponent. Yep, for number 11, what's in the box is a good answer. Yep. All right, go ahead and try the next 4 of those. They should all be either arithmetic or geometric, so figure out which one it is, find the next term, and then apply the appropriate formula from the top of the page. All right, you might not be finished with all of them yet, but that's okay. We'll go ahead and talk with them together now. For number 9, arithmetic or geometric? Arithmetic, adding 3, so the next term would be 14 then. And we'll use the arithmetic formula, which is the same one we used in number 8. So that's first term is 2 plus n minus 1 times difference is 3. When we distribute through and combine like terms, we should end up at 3n minus 1. Number 10 is also arithmetic, adding 10. So that means our next term should be 60. Using that same arithmetic rule, a sub 1 plus n minus 1 times d. When we distribute and clean that up, it ends up at 10n plus 10. You can always check your rule by plugging in some numbers. For example, plugging in 1 is usually pretty easy. If you plug in 1, you should get the first number in the list. If you plug in 3, you should get the third number in the list. So I would just do a quick double check of that. When you think you have the rule, make sure that it actually works for the numbers. there. Plug in a 1 should give you the first answer, plug in a 3 should give you the third answer, and so on and so forth.
You always have to follow the formula given on top.
You don't have to follow the formula given at top. It's possible to just kind of, for some people, to recognize a rule by understanding what numbers do.
I did like a sub n plus 1 times 10.
The a sub n minus 1 thing is that's a recursive rule. And these directions ask us to write a rule for the nth term, which means that I want to be able to just plug in a number and find that. As opposed to the a sub n minus 1 stuff, I would have to find every term up to that term. So it's a different type of rule. There will be a portion of the test that asks for a recursive rule, but otherwise we want the explicit. Number 12 is also arithmetic. It's subtracting 2, or we could think of adding a negative 2. So there will be first term plus n minus 1 times common difference is negative 2, adding a negative 2. Distribute that in and combine like terms, and I would end up with 12 minus 2n, or negative 2n plus 12. Thirteen is another geometric. Multiplying by 1/3 gives us a next term of 1 over 243. And our rule is the same one we did in number 11 there. First term times ratio to the n minus 1.
That's the simplest it could be.
It could also be just 1/3 to the n, but you don't need to do that.
So
It cannot be 1/9 to the n minus 1.
So when we get the same number pretty much next to each other, we can just combine that.
Right. Yeah, if they're the same number, the same base and first term, then you can combine them and just do it to an nth power. But if your first term and your base are different, then there's no easy way to combine them. Other questions on these? Ask for a recursive rule. A recursive rule is a rule that's based on the term before it. So every recursive rule has 2 parts. You have to give a starting place and then what to do after that starting place. Without the starting place, we can't proceed at all because everything is based on the last answer. So unless we have an answer to go from, there's nowhere to go. So on number 14, it gives you the starting term. You could just put a box around it if you want, or you could rewrite it, but in some way you must indicate to me that you know that that first term is actually part of the answer as well as part of the question. You have to give a starting term. Then, after that, we have to figure out what we do. So this one has an R in it. What does that mean? It's geometric. And what does geometric do? Multiplies. So in a geometric, we would take our last answer, which is a sub n minus 1. That's the notation that means last answer. And we would multiply that by our ratio. So we have to give our starting term that we start at 3, and then after that, we keep on multiplying by 0.2. And we know it's a multiplication because it has that R there, which means that it's geometric. So number 15, again, our first term has to be part of our answer. And what type of a sequence is this? An arithmetic. So from here we would say a sub n is last answer, and then what do we do in an arithmetic?
Add 4.
Add the common difference. So the sequence starts at -1, and then from there we just keep on adding 4. Question?
Where are you getting this equation or whatever that you're plugging into?
There's no formula. You have to know that R means geometric and D means arithmetic. And geometric means that we're multiplying each previous answer, and arithmetic means that we're adding each previous answer.
Yeah, but how did you know that it was supposed to be I know that it's a and then n minus 1.
A sub n minus 1 was in the lesson from Friday, and that means previous term. That's just the notation that means previous term. And that's what a recursive rule does, is it bases off the previous term and says, what do I do to that term? And in arithmetic, we keep on adding to the last answer.
So for recursive sequences, is it always going to be the an equals a minus 1 and then
Either multiplied or added. Yep. Yep, that first part will always be the same. That we're always going to have this stuff, and then either decide that for R, we multiply, and for D, we add.
that's all it is?
Yeah. Well, if that's all it is, if the sequence is arithmetic or geometric, which is all I'm going to test you on. But in the homework, there were many questions that were not arithmetic or geometric, so then it might be basing off of 2 previous terms, and maybe we added the 2 previous terms together, or multiplied the 2 previous terms by something. So in the homework, there was actually some more complex stuff in terms of not just looking at arithmetic or geometric. But for the test, we'll just look at arithmetic or geometric.
So we don't have to make our own rules.
So only in arithmetic or geometric, but not for a general sequence. So like one of the ones that you studied in the notes was called the Fibonacci sequence, which is 1, 1, 2, 3, 5, 8, 13. And that one has a much more difficult recursive rule because it's basing off of 2 previous terms. It's not just arithmetic or geometric. So in the homework, things were up a level from what they will be on the test. For this one, you would have to give 2 starting terms. And then what we do after that is say the term 2 ago plus the term 1 ago. So the homework was more complex and the notes were more complex. But on the test, we're just going to stick to arithmetic or geometric.
Will it be complex on the exam?
No, the exam will match the test. So for 16, it doesn't tell us whether it's arithmetic or geometric, so we have to figure that out. You have to give the starting term. Since it's not explicitly stated, you have to say a sub 1 equals 88. Because there's nothing to just box in there. It wasn't given already, so you have to state starting term. And then what do we do after that? We take our previous term and do what with it?
Times by a half.
Multiply it by a half, or you could say divide by 2. Either way would be fine. That we're either multiplying by a half from there or dividing by 2 from there. Okay? So that one was geometric because it was multiplying. The next group of questions wants us to find the sum of a series. So you need to recognize from our notation whether it's going to be an arithmetic or a geometric. Number 17 is going to be an arithmetic. Geometrics will have powers in them because geometric is repeated multiplication. So those rules have exponents. They have powers in them. If there's no powers there, then it's going to be an arithmetic rule for us. So then we can use our arithmetic sum formula, which is on the front. N is the top value of the summation. So N is 20. How do I find a sub 1? Plug a 1 into the rule. So that gives me 5. And how do I find a sub n? Plug the 20 into the rule. So that gives me 43. And then we do the arithmetic there and get 480. So if I added up the first 20 terms of that series, it would add up to 480.
Have you printed the test yet?
Yes.
I was going to ask you to move the formulas to the back.
Oh, should I put them on both sides? Yeah, you have to flip back and forth. I'm going to jump over to number 19. Number 9. Component on there. Okay, so when we have that power of n or I or whatever letter it happens to be, When it's an exponential formula, it's geometric. So then our formula is a sub 1 is 1 minus r to the n over 1 minus r. N on this one is 5. That top number gives our n value. A sub 1 is found by plugging in the bottom. So 3 to the first is 3. 1 minus, how do I know what r is? It's the one in the parentheses. It's the one that has the exponent. Whatever the base of the exponent is, that's our r value. And n is 5. Now when you plug this in the calculator, you have to be careful, either using a lot of parentheses or plugging it in multiple pieces. I like to do multiple pieces. So I go 1 minus 3 to the power of 5 equals. And then I go divide by, and your calculator will say a and s. And then I do the subtraction that's on the bottom in my head, so 1 minus 3 is negative 2. And I do that subtraction myself and hit enter. And then I go times, and the calculator says a and s, and I multiply by that 3 that's in the front. So I type it in multiple pieces. If you want to do it all at once, you need lots of parentheses so that your calculator understands your order of operations. So I think it's a little bit easier if we just break it up. And that gives 363 for that answer. Questions?
How do we get that 5 there?
5 is the n value. So the bottom tells us we start at 1, and the top tells us that we stop at 5.
Okay.
So 5 is our n value.
Are you going to give us the 2 formulas on the test?
Yep, they're on the front. On that whole list, there's 5 formulas at the top on the front.
Oh.
So they'll all be there on the front, so you'll have to flip back and forth.
How do you know the difference between these ones that are arithmetic?
The first two, like how do we tell whether it's arithmetic or geometric, or how do we tell which formula to use?
How do you tell whether it's arithmetic or geometric?
Okay. Geometric will have an exponent in it. So on number 19, it has that 3 to the I. When it has that exponent, that lets me know it's geometric. As opposed to like number 17 is just multiplication and addition. So that's arithmetic. It doesn't matter what the letter is. If it's an exponent, it's geometric. All right. Other questions on this type of problem? Okay, take a couple minutes and try 18 and 20, and then we'll come back together. Number 18, since there's no exponents there in the formula, this must be an arithmetic. So we're going to use the same formula that we used on number 17. So we're looking for the sum of 15 terms. Since the top number is 15, that's our n. So you get 15 times, plug in 1 gives 6, plus plug in 15 gives negative 8 over 2. And that gives us a total of negative 15. Number 20, since it has that exponent there, is going to be the same rule as number 19. So we're looking for the sum of 5 terms. Our first term is what we get by plugging in 1. And our ratio is whatever has the power. And then again in the calculator, you plug it in carefully in multiple pieces or with lots of parentheses. So I do 1 minus 8 to the 5th and hit enter. Then I divide by negative 7. I do that arithmetic in my head. And then times the 8 gives me the 37,448. Okay, so adding up the first 5 terms of that series would give me 37,448. Number 21 is also geometric, but it has a fraction in there, so we just need to be extra careful with the calculator on this one. So we're going to use the same formula that we did in number 19 for geometric. We're looking for the sum of 4 terms this time. A sub 1 is what we get when we plug in 1, so that's 1/4. 1 minus R, the ratio, is whatever has the exponents. That's 1/4. And n is 4. Now with this one, you just have to be really careful on the calculator as far as parentheses go. So I'm going to go 1 minus 1/4 in parentheses to the power of 4 and hit enter. Now in this one, we could do 0.25 and kind of save having to use parentheses, but if it was like a third, you can't do that. So just make sure that if you're plugging in a fraction, you put parentheses around that. Then I'm going to divide by, and it uses the A and S, the previous answer. Whoa, that's a big eraser. And I'm going to do that subtraction in my head and get 3/4, but that's still a fraction. So I'm going to make sure to put parentheses around it. And then I'm going to multiply that last answer by, in parentheses, the 1/4 that's in the front of there. So we just want to keep on building off the previous answers and making sure that every time you put a fraction into your calculator, you put parentheses around it. And that gives you a decimal that's pretty ugly. I will accept it, 0.332, and there's more stuff. But a better answer is to press the math button and turn it into a fraction of 85 over 256. I'd prefer the fraction. I'll accept the decimal. Question?
There's a way that you can make fractions without having to do parentheses or anything. You just press alpha and then you press y equals, so it's like F1.
That depends on whether you have the new operating system or not. So there are some other ways to do fractions, but I think it's just kind of easier to put parentheses around it. And that works for every calculator. All right. The next question asks us to find the sum of the first 25, so that's n, and we're finding a sum, so we're going to use one of our series rules. And it says it's arithmetic, so we're going to use our arithmetic series rule, which is n a sub 1 plus a sub n over 2. We're looking for the sum of 25, so n is going to be 25. What's a sub 1? 3. A sub 1 means first term. 3. A sub n would be the 25th term. We don't know it because they only gave us 3, 6, 9, 12. So we don't know the 25th term. So at this point, we're going to have to do a little side note and use our arithmetic sequence formula to find out what that 25th term is. Our first term is 3. N is 25, and the common difference is what we're adding each time, which is 3. So that gives me my 25th term is 75. So since we didn't know what that last term was, we had to do a little side note on it and use both the series and the sequence formulas in this question. Then we can do that arithmetic on the calculator. 78 divided by 2 and times 25 gives 975. Questions on that problem with having to use both of the rules? The next one asks for the sum of infinite geometrics, so we're going to use our final formula here. What's a sub 1? And r? One half. R is what we multiply by, so we're multiplying by a half here. 1 minus a half is a half, and 12 divided by a half is 24. So if I would add up all the terms of this thing forever and ever and ever and ever and ever, it's just going to keep on getting closer and closer to 24. It's going to be like 23.99999999999, and we'll just basically say it's 24. If I just start adding, I get 12 plus 6 is 18, plus 3 is 21, plus another 1.5 is 22.5. So we're already getting really close after just a few terms. Okay? And then adding up everything forever and ever after that is just going to bring it closer to 24, but never past. hold on with me to do the last question here. We are asked to write this in our sigma notation. We start at 1. Then we need our rule. This is arithmetic. We are adding, so you would use your arithmetic sequence rule. So a sub 1 is 8. Difference is 8. That would end up giving us a rule of 8n, which is what goes on the inside. At the top, a lot of students were making a mistake on the homework and putting 40. We don't want the last term. We want the n that gives the last term. So plugging a 5 give us 40. So we want a 5 at the top. Okay, and then that is the answer.